Hello students. So here we are discussing KVY SA paper part 2 of physics of 2020. So we are now looking at question number 2 of part 2 of physics. Now this is an interesting question. It says that there are two L-shaped structures. Okay, and one ball A is released from here, other ball B is released from here, and a third ball C is released from here. Okay, now after releasing A and B, we can expect from the uh, identical nature of the situation that whatever happens with ball A, the same thing will happen with ball B. Okay, so if ball A comes here and hits this corner with a certain velocity and then starts rolling onto this part with some velocity and leaves this end with a velocity, let's say V, the same thing we can expect here. B falls the same distance, strikes the same corner and leaves this part with a velocity V. Okay, subsequently, ball A passes through this point X. C ball has been released at the from here, and C ball falls and reaches point X, and B ball also reaches point X. Ignore this thickness, ignore this thickness. So all these three balls pass through the point X, and we are calculating time for each ball. Okay, for ball A and B, the time calculation began when these balls crossed this location. So uh, from here we are counting the time, like we have started the stopwatch for A when ball A was here. We started the stopwatch for ball B when ball B was here, and we started the stopwatch for C after releasing ball C from here. And we noted the time that these balls take to reach the point A, and the time was noted as TA, TB, and TC. Now, what we have to do is to compare TA, TB, and TC. Okay. See, this question can be addressed qualitatively, and there are few points also after finding the solution. Like there may be some queries that may pop up in your brain. I will try to uh, predict those queries, and I will try to address those queries. So first of all, if this distance is, let's say, x, okay, then time taken by ball B can be written as x by v. And if I'm talking about ball A, I can write the time taken by ball A in two manner. If I notice the horizontal motion of ball A, then I can write this time as x by v. So this helps me to claim that TA will be equal to TB. Now, if I note the vertical motion of ball A, okay, the ball A did not have any vertical velocity when it left this position. So this should be written as root 2h by g, where h is this height. Okay. And the same goes for ball C, because when we release ball C, it did not have any vertical motion. So this time also represents TC. So TA is equals to TC because of this factor, and TA is also equal to TB because we can write TA like this. So we can conclude that TA will be equal to TB, and that will be equal to TC. So here I think there is a small misprinting. One of these options should have been TB. So B option looks like the correct one because this is the only option containing two equalities. So hence I'm saying that B option is the correct one. Now I said that there could be some queries, and what could be those queries? So the first thing is it necessary that the ball should pass through this point X? Well, no, no, it's not necessary. But let's assume that we have put ball C in such a manner that it is vertically above the point through which this ball moves as it crosses this horizontal, or as it hits the, at whichever point this ball hits the ground, we are releasing ball C vertically above that point. So though it is not given in the question, but we can ensure that. Okay, we can ensure that. So that is one of the point. The second point is some of the students with whom I discussed this question, they claimed about using energy conservation at this point. Well, actually, that is not needed because the two structures are identical. Okay, so we don't really need to conserve energy here. Like they were calculating the value of this V by using this height. Let's call this height as capital H. So they claim that V should be written as root 2 GH, which is not true, which because this corner, uh, like it is not given specifically that this is a smooth corner without any jerk or but and the figure depicts it to be a corner, and there are chances that we energy loss can take place as the ball moves through such corners, but we don't have to consider that because if energy loss takes place here, it will also take place here. And ultimately, the fact that we have used is that whatever was the horizontal speed of ball A as it left the structure, the same will be the horizontal speed of ball B as it leaves the structure. And this statement is true whether the energy is conserved or not. So, if these thoughts were also crossing your mind, so I hope I have addressed those questions. So the correct answer to this question would be TA equal to TB equal to TC. That's a misprint. I'll correct it here. So that's it. So guys, I hope you liked this question. I hope you liked the solution. And thank you for watching and stay tuned for the next question.